back to Sharpest Online Tutorial. In today's tutorial, we're going to learn how to find the mean and the variance of a binomial distribution. And the binomial distribution, x is distributed binomial into parameter what? N, p. And the distribution function is given as what? Probability of x is equal to x, which is the same as what? N combination x, p raised to the power of x, then q raised to the power of n minus x at x raises from 0, 1, and up to n. So this is the function of a binomial distribution. Now we are asked to find the mean and the variance. But recall that sum of probability, which is sum of probability of x is equal to x, is the same as what? Is the same as 1. First, we are going to show that the sum of this probability is the same as 1. And probability of x given x is the same as what? The binomial distribution function, which is n combination x, p to power x, then q raised to the power of n minus x. So let's show that at x raises from what? 0 to 1, then the probability of x given x is the same as what? N combination x, p raised to the power of x, q raised to the power of what? N minus x. So we're going to take the summation of this function at x is equal to 0 and at x is equal to 1. So n, anywhere we see x, we are going to replace 0, then plus anywhere we see x, we replace 1. So at first, n combination 0, then p raised to the power of 0, q raised to the power of n minus 0. We just replace x as at 0. Then plus what? At x is equal to 1, n combination 1, p raised to the power of 1, q raised to the power of n minus 1. So n combination 0 is the same as what? Is the same as 1. Then p raised to the power of 0, you know any number raised to the power of 0 is the same as 1. Then q raised to the power of n minus 0 is n. Then plus what? N combination 1 is the same as 1. P raised to the power of 1 is the same as p. Then q raised to the power of n minus 1. So the whole of this quantity can also be written as what? Q plus p raised to the power of n, or p plus q all raised to the power of n. And recall that q, which is probability of failure, is the same as what? 1 minus p. So we recall this. So anywhere we see p, q, we are going to replace 1 minus p. So which is going to be equal to what? P plus, in place of this q, then I will replace 1 minus p, then all to the power of n. And remember, this is positive p and this is negative p, so they can cancel. So in this bracket, we are left with what? 1 raised to the power of n. And 1 raised to the power of n is the same as what? 1. So therefore, the sum of this probability given function is the same as 1, we have shown. Now we are going to the main thing, which is the mean and the variance. So first, we are starting from the mean. And mean, we call the mean is what? Expected value of x, which is equal to what? Summation of x probability multiplied by probability of x is equal to x. So remember that probability of x is equal to x of binomial distribution is what? N combination x, p to power x, q raised to the power of n minus x. Now we're going to substitute to this formula, which is going to be equal to what? Summation. Remember, at x raises from 0 to 1, x is raises from 0 to 1, x, then, sorry, to n. Then x, probability of x is equal to x is what? N combination x, p raised to the power of x, q raised to the power of what? N minus x. Is going to be equal to what? Summation at x, n combination x. This n combination x is the same as what? N over x into what? N minus 1, then x minus 1. Then p raised to the power of x, q raised to the power of what? N minus x. So that this x and this s is going to cancel. Then we can take this n out. So we take this n out. It's going to be what? Summation as n minus 1, then combination x minus 1. Then raised to the power of p to the power x, then q raised to the power of n minus x. But in this case, we're going to introduce something. You know, when we say p raised to the power of 1 minus 1, you know, 1 minus 1 is 0, then p to the power of 0 is the same as 1. Therefore, if you use that 1 to multiply by the whole of this, it's still the same, nothing changed. So we introduce p to the power 1 minus 1. So which is going to be equal to what? N summation of n minus 1 combination x minus 1 raised to the power of p to power x q raised to the power of what? N minus x multiplied by, do you know that this can also be written as what? P to power 1 multiplied by what? P to the power of minus 1. This is still the same. According to multiplication law of indices, when you multiply this, you are going to still get this thing back. Since the power are the same, then we add the two power, it's still the same. So what are we going to do? Which is going to be equal to n p to power 1 is the same as p. So we're going to take this p outside. It's going to be what? Np. Then summation of, remember, we have taken this one out. So it will remain only p to the power of minus 1. Okay. So summation at n minus 1 combination x minus 1 p and p. We have p here to power x and p to the power of minus 1. So when you multiply them together, remember, according to multiplication law of indices, write one of the base, which is pp, then we add the two power. So the first power is what? X, then plus minus 1 is the same as minus 1. Then q raised to the power of n minus x. So which is going to be equal to np, and the summation of all this is the same as 1. Sum of n minus 1, x minus 1, multiplied by p to power x minus 1, q raised to the power of n minus x. This is the sum of probability, which is the same as 1. So therefore, the mean, which is expected value of x, is the same as what? Np. So this is the mean. Now, the next thing we are going to look at what is the variance. Variance of x of binomial distribution, which is equal to what? Expected value of x squared minus expected value of x all squared. You know, we are finding expected value of x to be np. So we are looking for expected value of x squared. So expected value of x squared is the same as what? Summation of what? X squared, then probability of x is equal to x plus summation of x, probability of x is equal to x. So this is how to find expected value of x in binomial distribution. And remember that summation of x times probability of x equal to s is the same as what? Expected value of s, which is we find to be np. So the whole of this is the same as np. Now we're going to expand this. We have summation of, first of all, we substitute x squared. Probability of x given x is what? N combination xp to power x q raised to the power of n minus x. So in place of this is going to be what? N combination x p raised to the power of x and q raised to the power of n minus x plus, remember, this is the expected value of x, which we find to be what? So be np. So we just replace np. See, remember that x is raised from 0 to 1. X is raised from 0 to 1. Now, to get this x squared is the same as what? We can also rewrite x squared as what? X into the bracket of x minus 1 then plus x. Expand this bracket and simplify. It's going to give us back x to power 2 because x times x is x squared. Then x times minus 1 is minus x. Then minus x plus x is going to cancel. So it will remain only x squared. So this is equivalent to this. So we're going to pick only this part and substitute. So we're going to have what? Summation. So we're going to have summation. In place of x squared is going to be what? X into the bracket of x minus 1. Then n combination x p raised to power x q raised to power of n minus s plus np. So what are we going to do next? We're going to have what? Summation at x into x minus 1. Then n combination x at expected value of x squared is the same as what? N into what? N minus 1 over what? X into x minus 1. Then multiply by what? N minus 2 combination x minus 2. Then multiply by p to power x q raised to the power of what? N minus x then plus np. So this will cancel this. So now we are going to take this one out, which is n into what? N minus 1. Then summation of what? N minus 2 x minus 2 p raised to the power of x q raised to the power of n minus x multiplied by, we're going to introduce something. Here, if you remember, we introduced p raised to the power of 1 minus 1 at expected value of x. So at expected value of x squared, we are going to introduce p raised to the power of 2 minus 2. P raised to the power of 2 minus 2 is the same as p to the power 0, which is 1. So if you multiply 1 by this, it's going to give us back the same expression. So what do? We introduce p to the power of 2 minus 2, then plus what? Np. So which is going to be equal to what? N times n is n squared, then minus n multiplied by minus 1 is going to give us minus n. And summation of n minus 2 combination x minus 2 p raised to the power of x q raised to the power of n minus x multiplied by what? This can also be written as what? P to power 2 multiplied by what? P to the power of minus 2 and plus np. So what do we do next? We're going to take this positive p square outside. P to power 2 is the same as what? P to power of 2 multiplied by what? N squared minus n. We just take this p to the power of 2 outside, which is summation of n minus 2 x minus 2 p and p. Remember, we have left with this one. We have already take this outside, so it will remain p to the power of minus 2. And p to the power of minus 2, remember, this is p, this is p. The bases are the same, and according to exponential law of indices, we write one of the base, then we add the 2 power. X plus minus 2 is the same as what? X minus 2. Then what? Q raised to the power of n minus x. Then plus what? Np. So if we expand this, we're going to have what? N p squared multiplied by n squared is the same as what? N squared p squared. Then minus n multiplied by p squared is the same as what? Minus n p squared. And the sum of all this probability is the same as 1. So everything here is equal to 1. So we multiply it by 1 plus this plus np. So therefore, expected value of x squared is the same as what? N squared p squared minus np squared plus np. So now we recall that the variance of x is the same as what? Is the same as what? Expected value of x squared minus expected value of x all squared. So expected value of x squared, which is what? N squared p squared minus np squared plus np minus expected value of what? X all squared. And we find expected value of x to be np. So expected value of x to be what? Np. But from the formula, expected value of x is all square. So since it's all square, so we're going to share the square, n to power 2, p to power 2. So we have square both n and p. So the next thing is to simplify this. We notice that this is positive n squared p squared and this is negative n squared p squared. So this and this is going to cancel. And this can also be written as what? Np then minus np squared. So it's still the same. Now what do we notice here? We notice that NP and NP is common. NP is common here and also NP is here. So we factor out NP. Then NP divided by NP is the same as 1 minus NP squared divided by NP. It will remain only P. So therefore, the variance of a binomial distribution is going to be equal to what? NP. But recall that 1 minus P is the same as Q. So this place that we have 1 minus P, we are going to replace Q. So therefore, the variance of a binomial distribution is NPQ, while the mean, which is expected value of x, is NP. Thank you for watching, and please don't forget to subscribe to our YouTube channel and also follow us for more videos like this. Thanks.